right, I guess we're going to go ahead and get started. I don't want to necessarily cut off anybody coming in here, but I only have 5 hours to get through this, and I want to make sure we get it all. So, yeah, nervous chuckles. I'm right before lunch, aren't I? Yeah, I'm well aware of that. So I know that I'm standing between you and lunch. I'll try to make this as much worth your while as I can. I think it will be, but I don't want to press my luck and run 20 minutes into it. So we'll stay fairly close to the schedule here. So thanks for coming to this morning's talk on full stack reactive Java with Spring Framework 5, Spring Boot 2, and Project Reactor. My name is Mark Heckler. I am a principal technologist and Spring developer advocate with Pivotal Software Inc. Pivotal are the makers of fine software like Spring Boot, Spring Framework, Redis, RabbitMQ, Greenplum, huge contributor to Cloud Foundry, huge contributor as well to Apache Tomcat. You may have heard of us. We like to call ourselves a tiny little startup in Silicon Valley, although we're not terribly tiny, but we're still pretty darn nimble. So I blog, not as often as I'd like, admittedly, at thehecklers.com. And I tweet very regularly at mkheck. Is anyone here on Twitter? A couple people. That's not bad. It's 2017. Twitter is going to be a thing. Twitter is kind of where I spend most of my time. I'm kind of eaten up. I don't know that they'll ever turn a profit, but I hope they stay around. Because I live on Twitter from kind of sun up to sundown and parts in between, sometimes lying in my bed tweeting. So if you do need to get a hold of me, if you have any questions, comments, feedback, if perhaps you felt like I rushed through something, probably I feel the same way, and I'm happy to talk about it at length, ping me on Twitter. That's the easiest way to get a hold of me. But for those of you who are not on Twitter, hate Twitter, what have you, I'm also a member of the slightly older and more established social network called email. Is anyone on email? Okay, a couple more, that's good. I'm not quite as reactive or responsive or any of the R words on email, but I do check it from time to time. And I'm accessible at mark@thehecklers.com as well as my company email address. But be forewarned, I check my personal one more often and it's easier to remember, so take that for what it is. So who am I? I'm the author of several blogs and blog posts. I've co-authored a couple of books. I've contributed code and content to other books as well. And I'm a frequent conference speaker. I particularly enjoy it when somebody invites me back. This is the first time I've ever been able to make GeeCON Prague, and it's really cool, I have to admit. Any other first-timers? Yeah, it's kind of awesome, isn't it? I hope they invite me back. So if you have any you say in that, I hope you would rate me kindly so that they'll let me come back next year. But I also am as you might see from the next bullet point, I'm a software architect and developer. And as you might guess from the next bullet point, where most of my expertise lies, I was recognized by my peers as a Java champion a couple of years ago for contributions to the greater Java community. So if you had anything to do with that, thank you very much. Appreciate the vote of confidence. And I'm a seeker of a better way, as we all are, or we wouldn't be here, right? There's always a better way. Those better ways evolve, and you fail to evolve at your peril. So that's why we always keep on the lookout for a better way to accomplish things, or a way to accomplish things that may have not been possible or at least feasible in times past. So this is one of those cases. Reactive, which is what I'm going to be talking about, is not a silver bullet. It is not a golden hammer. It doesn't fix all of your problems magically. But it does have a very good solution to some very difficult or strange problems that may have been tough to resolve before. So it's certainly something that I think bears a lot of evaluation. This is kind of the summary statement. Ross Stoyanchev is one of our Project Reactor team members, and I love how he bundled this all together. In a nutshell, reactive programming is about non-blocking event-driven applications that scale with a small number of threads, with back pressure as a key ingredient that aims to ensure producers do not overwhelm consumers. Now, that's kind of information-packed, right? So let's unpack it a bit. We start with the first highlighted line, which is reactive programming is about non-blocking event-driven applications. What we have in the past, is anyone familiar with the term, the cake is a lie? Oh, good. Okay, I always can tell when I'm home. We've had kind of an artificial construct placed upon us because at the operating system level, typically things happen asynchronously, and yet when we hit the JVM, and for sometimes very good reasons, we've dealt with this blocking model where we issue a request, we get a response. It's very easy to reason about. But what happens is, as more work spins up, more threads spin up, right? And we spend a lot of time with block threads. We wait. We have wait states happening because we're kicking off a thread, we're issuing a request, that's busy, we go on to the next thread, so on and so forth. So at the operating system level, everything's very efficient, it's very asynchronous, but within the JVM, typically the model that we've employed is a very synchronous model. So we're looking here at more non-blocking event-driven type of models. That scale with a smaller number of threads. This is about resource utilization. It's about scalability. And sometimes folks ask, because obviously the first question that comes to mind for all of us is, what does this do to performance? How does this help me with performance? Probably not the right question to ask, because in certain cases, performance increases. In certain cases, it decreases. Again, not a golden hammer. But it does allow you to more fully utilize the resources you have, a smaller number of threads, to actually be doing things, keep things active versus having a lot of threads that are sitting there idle. And of course, the next point is a rather key ingredient as well, back pressure. Because in many cases, you have slower consumers. And what happens? If you don't have some form of back pressure where your consumers can push back, that's the term back pressure, what happens is they can easily be overwhelmed. And they're left having to try to determine what's important and what's not, how they deal with the number of incoming data items that they can't process and what have you. Reactive programming does not, and reactive systems in general, do not give you, it doesn't take that away from you, but it certainly places it on the producing service, the publisher, where you can have a bit better control over that. So it gives you more tools at your disposal to accommodate different scenarios on the publisher level, as well as ensuring that you don't overwhelm your consumers because you give them the knob to turn. Give me 2, give me 10. I can only handle a certain number, so I don't get overwhelmed. A bit of history. I'm a history nut, so I always like to dive back through the history. And by the way, computing history is awesome because what other field, whatever other historical subject can you go back all the way to the beginning to? I mean, we are so rich with history in such a short period of time, it's crazy. So I won't go all the way back, but I do want to kind of start with where reactive came from within our sphere of influence, within the Java sphere. Reactive extensions actually originated at Microsoft. Go figure, right? Eric Meyer at Microsoft R&D came up with reactive extensions for Java. I'm just kidding, not Java, .NET. But over time, different reactive extensions kind of crept into the panoply. So you had reactive extensions for JavaScript and Python and C and C# and pretty much everything, including Java. Now Netflix came out with RxJava, right? Version 1, version 2, they've kind of been the stewards behind this. But the key point is that this all kind of evolved. At some point, some very smart people got together, one of whom is here today, by the way. You'll get to hear him later this afternoon, Martin Thompson, and created the Reactive Manifesto. Now, all the stuff that I just said, forget it, because in our field, nothing really, truly, ever really happens until a manifesto, right? So all that stuff didn't exist. The manifesto is the beginning of all time. I'm kidding. Wow. Are my jokes that bad? Really? Okay. Well, you're stuck with me for a few more minutes anyway, so deal with it. So the manifesto basically said, recognized the shortcomings of a blocking approach and saw and laid out different philosophies and different approaches to how to resolve those issues. The Reactive Streams initiative came out of that. I'm skipping a lot of stuff in between here, but ultimately, the Reactive Streams initiative was formed by a group of companies and organizations that came together. Companies like Kazing and Pivotal and Red Hat and Twitter and Netflix and Lightbend. I'm trying to think if I probably missed a couple in there. But Reactive Streams initiative came about because at some point you have to kind of focus on the big hits, right? Grab that low-hanging fruit. And many of the issues that happen in terms of the gains that you can gain occur in that inter-process communication, occur when you're talking about data streams, when you can potentially be waiting and blocking in a blocking environment. So let's see, go on a little bit here. The Reactive Streams initiative basically is fairly simple. It codified three things. It had the API, the specification, and the TCK, the Technology Compatibility Kit. And all of these various different vendors and organizations can produce their own version of Reactive Streams, their own implementations, but they can be tested to be interoperable. So you know they will work. So whether it's Akka Streams or whether it's Project Reactor or RxJava 2. Whatever, you know that there is at least a certain degree of interoperability that's assured based on their passing the TCK. And this is all open source, so it's all out there for anybody to grab hold of. The Reactive Streams initiative itself, the specification, has 4 interfaces. Very simple stuff, very low-level building blocks. You have the publisher interface. You have the subscriber interface, again, fairly self-explanatory. You have the processor, which incorporates both a subscriber and a publisher for manipulation of the stream as it passes through, so to speak. And then you have the subscription, which is what a subscriber gets when they subscribe to the publisher. Simplicity and testability are key to adoption, but they aren't enough, right? Because these are primitives, and we must raise the level of abstraction to make it truly useful and to avoid that undifferentiated heavy lifting. This is very simple. It's deceptively simple. And these basic building blocks are in Java 9, right, with the Java util concurrent flow. The problem is that every time you want to do something with these, you're going to be building a lot of operators on top of them. They're building blocks, but they're very low-level granular building blocks. And that means a lot of repeat work. You could do that. Not recommended, but you could do that. Because it's not recommended, I say, because you've got a lot of, oh, that helps a lot, thanks. You've got a lot of different organizations who are putting in that effort for you, and a lot of different eyes contributing to the same set of code. By the way, I kind of got a little ahead of myself. I really do need to stop at this point and take a selfie with you all, because that way I can prove to my boss that I'm really here working, versus, like just checking out the coffee shops around Prague, which, by the way, awesome. But don't tell him I said, oh, this is recorded, isn't it? Never mind, I didn't scratch that. All right, so I'm gonna try to get most of the room here with a couple shots. Everybody, say reactive. Okay, let's try the other side now. Reactive. All right. Okay. Whew. Now I'll probably get paid this week. That's good. All right. So let's see. Anything else I wanted to cover? Probably, but we'll drive on anyway. So a quick overview of Project Reactor. As I mentioned, Reactive Core, and there are basically different segments, different components within, but the Reactive Core is a fully non-blocking foundation. It directly interacts with, it's very compatible and very similar to Java Streams, the functional API, completable features, what have you. So if you're comfortable in that already in that model, you're almost all the way there already. As I mentioned earlier, the publisher is a useful construct, but it's very low level. So what we've done is break out a couple of different specializations of that. So rather than just a publisher, which can mean 0 to infinity items, what we have is a mono, which is 0 or 1. So if you expect a value, but you maybe don't have one yet, or maybe you don't get one, that's a mono of a particular type. If you are expecting a number of different data points, a number of different objects coming back, then that would be a flux. So maybe it's an unlimited, an open-ended flow, an open-ended stream of values coming back to you. That would be a flux. So it's a bit more useful because there are going to be certain operations that apply to everything, any kind of publisher, and then there are going to be certain operations that apply more to one or the other, maybe apply differently. Again, the key is in the non-blocking inter-process communication. It's back pressure ready, includes network engines for HTTP, including WebSocket, server-sent events, what have you. So I find all that's kind of useful because it gives you a little bit of context, but I think the bulk of the understanding really comes about when you see what it does and how it does it. So let's code, right? Hopefully it'll go better than that. We'll find out. Okay. Now I do appreciate those of you in the front row because I have a special ask for you. Because, let's see. One thing I do want to point out, I do have like repos and other links at the end. Please remind me to throw those up because a lot of times I forget and then people come and say, hey, is there a repo? There is a repo. In fact, there are several repos or other helpful links. I do want to share those with you, so please remind me. The other thing that let's see, I need to mirror my screen. The other thing I need to point out, oh, that's much better. Okay, so let's blow that up. Better? Yeah, all right, okay. The other thing I need to say is that occasionally I will throw in typos into my code just to see if you're paying attention, okay? So front row, I mean, it's much easier for you to catch them because you're closer, right? Let's say front 2 rows here. So if I build and I've got a typo in there, it's all on you, okay? No pressure, all right? Okay, so is anybody familiar with this site? Okay, a couple more people. That's really good. I'm kind of wondering about the rest of you. You're not JavaScript folks, are you? Whew. All right. Anyway, this is kind of your starting place for microservices, for Java-based microservices, right? And it's not just the blocking kind. Now you've got fully reactive microservices you can build starting right here. This is the Spring Initializer, also known, I'll do this just as an homage, as start.spring.io, right? So you can get to this any way you want to. You can curl it. You can use the Spring command line interface. You can go to the site itself. I like to go to the site because it's so pretty, right? This just brightens my day. All right, so I don't have a great eye. But anyway, it is nice. It does work really well. So we'll start there. And, oh, that's good feedback. Pivotal, a lot of times will say this is opinionated. Things are opinionated. And it always kind of bugged me until I figured out what opinionated meant. So Spring Framework is an opinionated framework. Spring Boot is an opinionated tool set. Cloud Foundry is an opinionated platform. What does that mean? Is anybody an old-timer in the Java community? Yeah, me too. So you remember the bad old days, right? Where the frameworks gave you really most of the time one way of doing anything. And if you tried to do it any other way, too bad you couldn't. Those were the bad old days. An opinionated framework, an opinionated tool, kind of clears the way and makes it very simple for you to do things if you fall within that 80 to 90% use case. Dead simple. If you need to do something that falls in that other 10 to 20%, you still should be able to do it. It just may take an extra few lines of code. No big deal. You can get there, but we actively help you with that as well. But that 80 to 90% use case is just smooth, right? So this is another example of that. The Spring Initializer is all open source. It's an opinionated way to get started with microservices, with Spring-based microservices. Excuse me. So as you can see, it's very simple. You have very few things that you can go ahead and configure, need to go ahead and configure to get started. You can switch to the full version and configure to your heart's content. You can choose off this menu and go crazy, but you don't have to. And I like that. So I'm going to switch back to the simple version. Keep it simple. I try to keep everything fairly simple and approachable during the demo. We can talk at more length later or afterward. The bad news is we have a short amount of time here today, so I scope things down. The good news is it's very open-ended afterward, so happy to talk at length anytime. So let's go ahead and create a project. Spring Initializer, again, gives you some basic defaults you can choose from. If you're a Maven developer, you can choose to create a Maven project. If you're a hipster, you can choose to generate a Gradle project. I'll stick with Maven today. All love to you Gradle folks, that's fine. We can do that, but some other time. You can choose to create a Java, Kotlin, or Groovy project. Any Kotlin lovers here? Yeah, I'm digging into that, loving it. I'm going to stick with Java here today, but the repo that I show you at the end, I do have a fully idiomatic Kotlin version of the service that I create. So go crazy. If you're a Groovy developer, sorry I don't have a Groovy version out there, but I do take pull requests. So just saying. So we're going to choose Java, and then I'm going to choose Spring Boot 2.0 milestone 5. Now the reactive bits, you have to go all the way up to the preview versions for right now. Spring Framework 5 shipped a couple weeks ago, is right after Java 9 shipped, fully Java 9 compliant. Spring Boot 2 comes out in December. So you'll have the full thing, reactive bits, GA, everything by the end of the year. Right now you can still get to them. You can pull down the bits, you can pull down the code and build it yourself. I'm going to go ahead and just choose that, and we'll start from there. Now, Josh and I, my colleague is Josh Long, and we got together and kind of worked this session up, the content, the prezo and all that, several weeks ago. And we wanted to come up with some different demonstration, some different use case than what you would typically see. You know, the chess programs and the chat programs and all that. I mean, those are cool, but we just thought they'd kind of been done, right? So we wanted something completely novel and new, something that nobody had done before that we could demo that would really, really be cool. So we got to thinking, maybe, I mean, how cool would this be if we developed an application that would stream movies over the internet. So movies are sometimes referred to as flicks, right, in the vernacular. And of course, we could shorten internet to net, so we kind of thought, why don't we call this Netflix? So we started putting in all the work, we put everything together, we went to register the domain and found out that somebody already had it. So never let that be said that we would let that deter us, so we went ahead and started anyway. Then once we got the lawyer letters, we thought probably we should rethink this. So we decided to rename it, and we renamed it Fluxflix. Because we really don't care about all those other movies, right? All the movies that don't have anything to do with reactive programming. We just care about the geeky stuff. And that's all you care about, right? Action adventure, who cares? Romantic comedies, who cares? Unless it has a reactive bent to it. So that's what we're going to be doing today. I'm going to create a service that will stream reactive movies, okay? So I'm going to bring in a few dependencies here. As you can see, we have fully reactive security baked in now. You're not going to be blocking to get validation, authorization, authentication. But I'm going to just focus on the basic core elements today, that kind of minimum viable product. So I'm going to bring in the dependency for Reactive Web. Now, this is one thing that I didn't mention earlier that I love to point out, because there are a lot of companies who will produce a fully reactive stack who effectively tell you, you know, the last 10 or 20 years of effort you've put in building that expertise in your stack of your choice, throw it away. Do it this way. It's an entirely different way. You have to do it this way. And that's fine. It's not like that's a bad approach. But this is one thing I feel like the Spring team is doing really well. If you have expertise that you've fought and won over the last several years, we don't tell you to throw that away. You can apply that very similarly to a reactive model. And again, this creates a lot more effort on our part because we have two parallel packaging, two parallel modules that we're going to have to maintain, various code lines. The good news is we can apply lessons learned from one to the other. The bad news is it takes a lot more effort to maintain that. But it also means that you can bring your expertise with you and apply that immediately to create a fully reactive stack, top to bottom, which I think is kind of cool. If you're into the more functional reactive programming, that's fine too. We've got you covered there. I'll show you a demonstration of that as well. But we'll start off with this. If you're a Spring MVC developer, you know that Tomcat by default is bundled in. We're actually defaulting with Netty for our engine as a default, but any, Servlet 3.1 engine can be used. It's just Netty is first mover and obviously very well established in this realm, so we use that as a default. I'm going to bring in the Reactive Web dependency. I'm also going to bring in Reactive Mongo dependency. Now, Spring data as of version K, it's all alphabetical, so I don't remember what J was. I was Ingalls. K is just K, K-A-Y. But from Spring data K on, we have reactive support for databases that have reactive drivers. We do not have reactive JDBC. You know why? Because that is inherently blocking. We don't have reactive JPA. Now, there has been some noise made about perhaps an asynchronous JDBC capability. Time will tell, right? But it makes no sense to bolt a fully reactive program on top of a blocking database call, because all you're doing is potentially adding some complexity up top, and then you're still blocking, which again, going back to streams, is kind of what you're trying to avoid in the beginning, right? So we're not going to be bolting on reactive mechanisms on top of a blocking database engine or database drivers. So as you can see, Spring Data K incorporates Reactive MongoDB, Cassandra, Redis, Couchbase is also available, as are others coming online pretty much weekly. But we'll start with Mongo. Mongo was the first ones out of the gate. And as much as we like to pick on Mongo, they do have some fine stuff. So I'm going to work with Mongo today. I'm also going to bring in Lombok because I'm a lazy developer. Lazy is good when it takes your time out of maintaining mundane stuff and focusing on business value. So that's my justification. So I'm going to do that. I'm going to go ahead and generate the project. And let's see, dump that on the desktop. We'll go here, and I'm going to open that. And we'll open that in our favorite IDE, which right now for me is IntelliJ. Whoops, I forgot to change my settings. So let me go here, font. Here we go. Let's blow this up just a little bit. Let's see. Put that up to my ambiguous setting. Okay, so is that good in the back? Can you see that? Yes? No? Yes, okay. I'm counting. Okay, this is the back row part. You guys have to tell me, guys and gals, if you can't see that, and I'll go ahead and blow it up some more. But I would like to actually get a couple of class names on there before it gets, starts to. Okay, so the first thing I'm going to do is create my domain, right? My domain classes. So I'm going to create, since this is a movie streaming service, we're going to create a class movie. Kind of makes sense, right? So what kind of member variables do we need? Well, we'll need probably an ID field and maybe a title. And we'll start small. We'll build out from there. Now again, I'm going to annotate this as a document for Spring Data so that it understands that we're wanting to persist this. I'm also going to, as I mentioned, use Lombok. Annotating with that data gets me a few things. It gets me my toString, my hash code, my equals. It also gets me my getters and setters, which is really nice, just kind of out of the gate. I'm going to ask Lombok to provide a no-args constructor and a required args constructor, and then I'm going to annotate this as a non-null field, right? And then, of course, I'll want to annotate this as my ID. And that's it. So the code you don't write can't go wrong. So we took care of that pretty easily. I'm also going to want to create a class that's more of an operationally focused class, right? I'm going to create a movie event class. Because as we start streaming these movies, we want to observe what happens. If we have a movie in our collection that maybe somebody's only streaming once a year, we probably don't want to keep that movie in our collection. If we have another movie that's streamed 100 times a second, we probably want to explore similar titles and bring those into our collection as well. So I'm going to create a class to track movie events as streaming starts. So let's see, private string movie ID for a particular movie, and private date when, so when the streaming starts. That's good, and again, I'm going to annotate this at data, and a no-args constructor, and an all-args constructor for this one, right? The only other thing that I need to do is create an interface. We'll make a movie repository, and we'll extend our Reactive CRUD repository. This is an interface. I'll actually go out and show you that. This is an interface that's defined in Spring Data. By extending this interface, defining an interface within your code that extends a Spring Data interface, Spring Boot sees that. It picks that up. It sees that you have a data driver on your class path, and it says, hey, I know what you want. I know you want a proxy that will interact with your data store as a repository. Kind of makes sense. So that's exactly what we're going to do. I'm going to specify a movie repository for objects of type movie with IDs of type string, and that's it. So that handles things reactively, but I'm a very visual person. I like to see what's going on. So what we want to do is create some sample data, right? And I'm going to create a bean that implements the command line runner interface, which again is another interface. This is a functional interface with a single abstract method. Is anybody aware of what you can do, what you can use to implement that? Okay, stunned silence. All right, so you can actually supply a lambda as the implementation. So I'm going to do that. I'm going to inject my movie repository, return args, and there's my lambda. So I'm going to create some sample data here. Now this is the absolutely most critical part of the entire demonstration. This is a very data-driven demo. So the data is critical. If you don't give me good data, everything fails, right? The whole dang opera falls apart. I'm a big movie fan, so I quote movies throughout. So if you recognize them, just throw up your hand and yell it out. I have no prizes to give, but at least we'll bond, right? So I'm going to create a flux of just these values. And we are going to create some movie titles or some titles based on movies which have a kind of a reactive focus. or even Java 8 streams and lambdas type of focus. So let me just start you off with what I'm thinking of. Phil Webb, co-creator of Spring Boot, came up with this little gem. The silence of the lambdas. Nice, huh? So jealous. Oh, he got there first. I would have probably never thought of it, but anyway, just brilliant. Let's see, things maybe like enter the void, right? But in this case, we'll do enter the mono void, if I can type. Front row, second row, your work's cut out for you today. So any others? Can you think of any reactive movie titles? Don't be shy. Anyone? Bueller? What? Transformer. Oh, that's good. Okay, the Transformers. All right, we'll go with that. Anyone else? Come on, you want this to be a good demo, right? Oh, can I do Blade Reactor? Blade Reactor. That's brilliant. Okay. All right. Anyone else? I have one that I thought of. Is anybody familiar with the Alfonso Cuarón movie, Y tu mamá también? Okay. Well, this has like a double bonus because that in Spanish, any Spanish speakers, Hispanohablantes? So, y tu mamá también, and your mother as well, literally. So if you change that a bit, you get y tu mono también, right? Which, again, the added bonus is mono in Spanish is monkey. So it goes from mother to monkey. That killed him in Barcelona. I guess maybe it's location sensitive. All right. So let's see. Anything else? Nothing? Meet the Fluxers? No? Really? Wow. Okay. Anyway, well, I'll tell you what. If anybody thinks of any throughout this, just yell them out. Just stop me and yell them out. This is very important because the whole thing hinges on this, all right? I think we might have enough, but if not, we'll come back to this. So we'll take these values. This is a flux of just these strings, right? And we're going to map these titles to a movie, right? And then let's flat map that. We'll take each movie, and we'll do a movie repository.save of our movie. And then, just like a stream, we have to have a terminal operation, right, to kick things off. So what I'm going to do is just do a subscribe, right? And we'll just print them out so we can see them. Because again, seeing is believing. So that's pretty good. We've got a couple things we can fix. So if you have a lambda, you can replace that lambda with a single parameter. You can replace that with a method reference, so that cleans that up just a little bit. I just like it. It's a little cleaner. But we have a slight problem. I mean, there's no bug. I never bug my code, so I never have to debug it. But there's a slight problem because we're going to be restarting this throughout several times. And each time we restart this, we're going to be adding these same records to our database, right? And I know we're using Mongo, but even with Mongo, it'll probably save at least some of them. So we probably do want to clean things up to begin with. So I'm going to take my movie repository and then do a delete all, and block. Oh. The whole idea behind reactive programming is not to block, right? Now, I mean, obviously, this is a valid operation. It's legit. It's in there. It's in the API. But when you see .block, you should probably rethink your life choices. That's kind of a red flag that maybe, just maybe, there's an idiomatic way to do something that would get the same thing done. So what, and in fact there's a then many, which takes a publisher and returns a flux. So it returns a specialized publisher, a flux of something. So we're going to use that. And by the way, this right here is a flux, right? So we have what we need. So I'm going to go ahead and clean this up just a little bit. And there we have it. So we're going to go ahead and clean things up. We'll delete all the records from our movie repository. And once we receive the signal that all is clear, we can go ahead and proceed. We do automatically. So we'll go ahead and kick this off, make sure everything's running. And of course it will be. Ah, look at that. Okay, so we have movies. They're in our database. Life's good. So from here, we've just written down, we've handled the reactive interactions with our data store. And that's a good start. So what do you think we need to do next? Probably we should define a service API. So that's what we'll do. I'm going to create a service called class movie service, and I'm going to private final movie repository, and I'm going to inject that so we can leverage that. And let's define our internal API. So we know we're going to want to do a few things. We'll probably want to return a flux of all movies, right? Get all movies. And we'll probably want to be able to return a particular movie, so mono of type movie, right? Boom. Get movie by ID, passing an ID, right? We'll do a minimum viable interface here. So let's see. We'll also want to return a flux of all movie events, so we can keep an eye on what's happening with our streaming. So we'll do get events, again, for a particular movie ID. And that gets us started. So let's go ahead and implement this. So to get all movies, we'll do a return this.movie repository, find all. Straightforward, simple pass-through. To return a particular movie, we'll do a return this.movie repository, find by ID, passing our ID. Again, fairly simple. Here's where it gets a little trickier. Because if we had millions of subscribers, these movie events would already be there, right? When somebody starts streaming, we'd probably add that to an in-memory grid. So we would have these movie events that we could just kind of query and return. Right now, we don't have millions of subscribers. We don't even have a subscriber. So if you were to subscribe, you'd be the first subscriber. I'm just planting that idea, okay? But anyway, so we don't have these, so what we need to do is just generate some. We're going to fake it till we make it. So I'm going to do a flux.generate, and I'm going to create a synchronous sync so that we can just generate some of these for the time being. New movie event. For this particular ID, we'll create just do a time date stamp. Now, that generate will generate just as many items, as many movie events as this little machine can generate in as short a time as possible, which is kind of overwhelming for a demo. So I'm going to slow things down just a little bit. I'm going to delay the elements to just 1 per second. So that means that we can see what's happening, kind of a blip as they come through. And that's pretty good. Oops, let's see, there we go. Now I need to specify I'm actually wanting to return movie events, and that should work. If only there were some way to test this. If only there were some way to test code before putting it into production. I don't know. I was talking to somebody out in the hallway just a few minutes ago, and they said, you know, I think there is. Let's see. Yeah, look at this. So apparently you can create tests now. This is really cool. So I'm going to try this, and we'll see what happens. I don't really care right now for the, checking the get all movies, get movie ID, but I am very concerned about this one, right? Because we're faking this method. We're going to make sure it's actually working. So I'm going to just see what happens here. I'm going to do a run with spring runner.class, annotate this as a spring boot test, and let's create a test. I'm going to auto wire, private, let's see, movie service. Okay, now I'm going to rename this, because it's always good to name your tests a little more explicitly so you can see what you're testing, right? So I'm going to take 10. This gives me another chance, or a chance to show you a little bit about back pressure as well. So the first thing I'm going to do is grab a movie ID to play with here. So I'm going to do a movie service, .getAllMovies, .blockFirst.getID. Now, testing is one area where it's okay to block, right? In this case, all I'm doing is telling my Mongo repository to give me back all movies but stop at the first one. Because all I really care about is just getting a random movie ID. So that's fine. That's the one exception. But here, I'm going to use step verifier. When you're testing in a blocking model, it's relatively much simpler than testing in a reactive model, right? Because when you're blocking, all you're doing is, what you're doing is issuing a request, getting a response, testing and evaluating that response. But what happens when you're testing and evaluating, or you want to test and evaluate, a stream of values that may come very sporadically? So you may get 3 values in 3 seconds, you may get the 4th value in 10 seconds, maybe the 5th in a minute, and maybe the 6th, 7th, and 8th values after a week. How do you test for that? Well, you need some way to time travel. This brings me to my second most favorite part of this talk, is the time travel portion, right? Right? Yeah? Doctor Who, extra points? Nobody? Really? Oh gosh, okay. Your mission tonight is to stream some Doctor Who. Again, notice what I said there, stream some Doctor Who. Anyway. All right. I know, it's bad, but yes, sir. Sure. Back to the function? Okay, we can do that. All right, so let's see. Back to the function. All right, cool. We will pick that up momentarily. Thank you very much. See, somebody was paying attention. This is good. Okay. Yay, all right. Okay, so I'm going to use step verifier, which is a reactive mechanism for testing with virtual time. We're going to time travel a little bit here. So I'm going to create a supplier. Whoops. So let's see, I'm going to do a movie service dot get events for the particular movie ID. I'm going to take 10. This is back pressure in action. I'm saying, look, I can only handle 10. Just give me 10. No more, no less, just give me 10. And I'm going to collect that into a list. I'm then going to await a certain amount of time. Now we know, because we wrote the code, we know that we're going to get one value about every second. So we could wait 10 seconds, would probably be okay. I'm going to give it a little bit of extra leeway here. I'm going to say duration of 10 hours, because we're time travelers, right? What's time? So then I'm going to do an assert next, and I'm going to take my list that's produced, because again, I'm collecting this to a list, and I'm going to assert, let's see, that the list size equals 10, which it should, right? We know it should, and then I'm going to verify complete. So let's see what happens when we run this. Okay, hey, it's green. Green bars are good because that either means your code works or your test doesn't. So let's go back and let's make sure that the test is correct, because it's always good to verify, right? Trust but verify. So let's go ahead and rerun this. And it should be red. Oh, good, it's red. Okay, so now I'm going to just undo that and rerun it again because I'm kind of OCD that way. I just like to make sure everything's clean and it's working as we expect it to. Oh, that's good. That's so nice. Okay, so we've got a green bar. That's good. Now go ahead and close this out, and let's get back to our application. So we know everything works. Our internal API works. So what do we do now? Let's blast this out and create an external API. I'm going to create a REST controller. And I'm going to map this, request mapping, to /movies. That's where we'll build everything from. We'll call this class movie controller. Private final movie service, because we're going to build everything again around our internal API. I'm going to inject that, and we'll do a get mapping, public, Flux, movie, let's see, all, right? We also want to do a get mapping / ID to return a movie of particular ID. Let's see, public, mono, movie by ID. We're going to take a path variable with our string ID. Okay, and let's see, one more. Yep, get mapping for a particular ID for the events. And again, we'll return a public Flux movie event. Events. Again, taking our path variable, string ID. Okay, so we've already done the hard work. Let's just make this happen. Return this .movie service .get all movies. And for our by ID, return this .movie service .get movie by ID, passing our ID. And then finally, for our movie events, return this .movie service .get events, passing our ID. And that's almost enough, right? But as it stands, these will return application JSON. Since we know we have a lot of values for our movie events, in fact, we're going to be getting one a second, just in perpetuity, forever and ever. We need to use some mechanism other than loading everything into a single document for it to be interpreted at one time. We get away with that with our movies because we have a very small set of them right now. But we can't get away with that for our movie events. So we need to somehow specify that we're going to use something like server sent events or WebSocket, which are both supported by Project Reactor. Since this is a one-way push, I'll be using server sent events. It kind of lends itself really well to that. So I'm going to specify a media type, let's see, media type of text event stream value, which instructs our controller to provide this as a server sent event stream. So I'm going to go ahead and restart this, and we'll see what we get. And while that's starting, let's see, boom, boom. Let's see, actually that's pretty small, so let me blow that up where we can see it a little better, right? Better? Oh, what happened here? Oh, yeah, sorry. It helps when you close everything out. So let's see, close. Okay, let's try that again. Port conflict. Okay, we're up and running. So I use HTTPy. You can use curl, but I like this because it's very nice. If you omit the host name, it assumes localhost, which is what I'm running on right now. And we get back our list, our flux of movies. I'm going to go ahead now and grab a particular one. We'll grab back to the function because we just added that in. And we can retrieve a mono of type movie, which is what we did there. Now I'm going to grab the events for that. So we go back here, and we see if this works. And of course it works. We don't make mistakes. And the front and second row did not let me down. So we're good. So this is good, right? And this is very similar. If you're coming from a Spring MVC world, this looks very similar, right? The only thing that really looks different is your return types. That's because you're relying on Spring Web Flux to do the work that Spring MVC does for you normally to return a particular type. You're returning a publisher of type. Very simple, very low impact in terms of coming over and bringing all that knowledge you've built up over the years with you and still leveraging a fully reactive stack. So it works, but we can fix it, right? So let's go ahead and break this. Because what if you're not coming from a Spring MVC world? What if you're coming from more of a functional reactive world? So I'm going to show you that, how you can define your routes functionally. I'm going to create another bean. Let's see, router function of, let's see, server response. Nope, response. Yep. So let's define our router function. Return router functions dot route. So let's define our routes functionally. So I'm going to say request predicates dot get, and I'm going to create a get. Let's define our endpoint. Whoops, let's make it work here. Movies, right? And at this point, we need to provide a handler function. Ugh. That's ugly, isn't it? New title? Yes? Total reflux. Okay, we can do that. All right, so let's go back. Comma. Total reflux. Got it. Okay. Perfect. Okay. So, y'all are messing with me now. That's good, though. That's good. Okay, so you see what we require here. For our route, we have to specify a particular request predicate. In this case, we have a get on /movies, right? And we need to provide a handler function. This is jarring because you know what this is? Does this look familiar? Well, all we really need is this handle method, which takes a server request and returns a mono of type server response. But we're having to create an anonymous inner class to do this. That's ugly, and that's so pre-Java 8. So we can fix this. What can you do if you have that situation? Instead of an anonymous inner class, you can do what? You can provide a lambda. So what I'm going to do, probably the cleanest way, is to create a bean, which is my movie handler. And we're going to, again, leverage private final our movie service and inject that. And then I'm going to create some handler methods here. So in this case, we're going to create our method for all, right? We also want to be able to return by ID, and we also want to return all of our events. So in this case, we're going to return a server response.ok. And for our body, we will take our movie service and get all movies, return objects of type movie, right? Pretty simple, pretty straightforward. In this case, for by ID, we're going to want to return a server response.ok and a body of, let's see, movie service dot get movie by ID, passing in our server request, extracting the path variable of ID, and returning, again, objects of type movie. This is a little bit different for our events. We're going to want to return a server response.ok, and our body, again, movie service.get events, passing our server request, extracting the path variable, and returning objects of type movie event, right? But in this case, again, this is a server sent events. We have an ongoing stream of these, so we need to specify a content type. In this case, once again, we're going to specify our media type of text event stream, and that's enough. So we defined our handler methods. Now we can go back up here and get rid of this ugly monstrosity, right? So let's get rid of this anonymous inner class. Oh, and I do need to inject our movie handler. So now I can do something like this. Request and handler.all, passing our request. And then let's define another route and route, request predicates.get. In this case, it's for /movies/ID. So we can grab our handler by ID, passing our server request. And finally, we'll create our final route, which is request predicates.get for /movies/ID/events. And once again, server request, events, passing our server request. And this isn't horrible, but I think we can do a little bit better. So what can you do when you have a single parameter lambda, right? We can replace that lambda with a method reference, which tightens that up quite nicely. So we'll do that here. And then we can also do an on-demand static import here in a couple places for our request predicates and what have you. Oops. Let's see. Whoops. Back. Boom. Boom. Okay. That is much cleaner, right? Much better to look at. So let's go ahead and restart this and make sure I haven't introduced any bugs. That never happens, right? So let's see. Boom. Plus that grabs our extra movie title. So let's see. Here we go. So we're up and running. So let me clear this. And we'll go back to our movies. All works. Let's see. Total reflux. That was a new one, right? Okay, so we've got that. And let's grab our events for that. Whoops. Let's see. Boom. Okay, everything works. Yay. All right. Let's see. Time's up. Oh, and I didn't even get to the web client. Okay, so what do you think? Do you want a couple, 3 more minutes? You want to just call it a day? Sure? Okay. All right. Well, if you want the repo link, stick around. If you don't, well, you know, I get it. But anyway. Okay, so let's create a client. Because so far all we've done is create a reactive service, which again is reactive all the way to the metal, right? Fully reactive stack, all the way down into the interactions with our data store. But what happens if you want a consuming microservice? Because this is all in microservices architecture, right? We need a reactive client. So let's create one. Client, a Flux client. I'm going to remove Mongo because we don't need that for our client. So let's see, we'll save that. This is going to be a lightning round. So let's open this up. And we'll go here. Boom. There we go. I'm going to go to my application properties so I don't get another port conflict, 8081, just for grins. Go to our main application class. I need to recreate my domain classes. So let's see, class, movie, private, string, ID, title. Yep. And let's see, at data, at args constructor. That should be good. Just in case, at no args constructor. And then, of course, we have our, let's see, at data, at no args constructor, at all args constructor, class, movie, event, event, private, string, movie, ID, private, date, when, right? Okay, good to go. All right, so let's quickly do this. What we're going to want to do first is create a bean, create a web client bean. So return web client.create. You don't have to provide a starting point for our URL, but I usually do because, again, everything that we're doing for this particular demo is based off of local host. I need to slow down. I'm getting too fast, and now I'm making typos horribly. So localhost movies. So that provides our starting point. Next, I'm going to create another command line runner bean so we can use our demo and inject our web client. And again, return args, boom. Okay, so client.get. And I'm going to retrieve. We don't have to add anything to the URI because we already have a complete endpoint already specified. And then I'm going to create or convert that body to a Flux. In this case, it's objects of type movie, right? And then let's filter this down to 1. So we take a movie, and let's grab equals ignore case. Which one's your favorite movie? What do you want me to pull? What? What? I'm just going to go with Blade Reactor because I think you guys are just messing with me now. All right. So, and as much as I appreciate a good joke, I am the only heckler who's supposed to be in this room today. So, okay. So I'm going to we filtered this down to one particular movie. So I'm going to take that movie now. I'm going to do a client.get once again. But now I'm going to add to the URI. I'm going to add a particular ID and grab events. And we'll take that movie and do a get ID so we can map that properly. And then I'm going to do a retrieve on that. And then let's do a body to Flux, convert that to a movie event, right? Each one to a movie event. And then let's subscribe just so we can see what we've got and make sure it works. And that, as they say, is that. So as long as the front two rows did not let me down, we'll have a working example of a reactive client, and we can call it a day. Look at that. It even works. Okay. All right. Okay, so in a nutshell, that's it. I'm going to, let's see, let me go back here and pull this back up. And you get to watch moss burn one more time. All righty. So long. It's been good. Okay, so here are some helpful resources. Again, we start off with the Reactive Streams Initiative. This gives you your background, all you need to know, all you care to know about Reactive Streams Initiative. It has links to the GitHub repos, so you can see all the code developed in the open. Project Reactor, which is ours. Project Reactor is a dependency of Spring 5 and of Spring Boot 2, but it is not the other way around. So if you want to use Project Reactor in your own non-Spring projects, I don't know why you'd want to do that, but you can. But of course, it's baked into Spring as well. So you get all of that functionality, quote, for free. It's in there. And the next one, the third, next to the bottom, is exactly what you saw today, plus a few extras, including an idiomatic Kotlin version of the Flux service. And then the final one is Josh's in my repo, where we add all that and more. We've also pressed into service some of the Spring security team to add the reactive security mechanisms to that as well. So all kinds of goodies in there. If you'd like to explore them, please do. And please give us some feedback. Finally, just thanks for coming. If you have any questions, comments, feedback, I am available. And by all means, please do rate this favorably if you liked it. And maybe they'll let me come back next year and continue the talk, finish the talk. So thank you very much.